Now we'll discuss the another concept, that is electric motor. So actually electric motor the working is not in your syllabus, but still then I will explain here. But students are advised not to remember the working part mainly, how the electric motor works. Okay. So first we will discuss what is a motor. Electric motor means what is a motor? Motor is a device which convert electrical energy to mechanical energy. You have noticed that the motors are used in various electrical equipments like CD player, grinder, fan, etc. in water pump. Okay. So in various things you will notice that the electric motor is used. Motor means a moving part. Okay. That means they use the electrical energy and change it to mechanical energy. So what is a motor? First you write down in your copy. It is a device which converts electrical energy to mechanical energy. Second, it based upon the principle that the previous one, the concept which you have discussed. It based upon the principle that a current carrying conductor experiences a force when placed in a magnetic field. It based upon the principle that a current carrying conductor when placed in a magnetic field, it will experience a force. Using this principle, the electric motors are made up of. Okay. So a rough diagram I am doing here. Let's say this is the core of the horseshoe magnet. That means or opposite pole of 2-bar magnet, north south. Okay. It has 4 parts. First one is NS magnet. That means a strong magnetic field is created here. Okay. Second, ABCD armature coil. So inside the core of a horseshoe magnet, ABCD, a armature coil. Here I am showing you a rectangular armature coil in which number of turns of wires are made. Okay. So this is a schematic diagram of a motor. It has 4 parts. One is north-south magnet, strong horseshoe magnet, or core of a strong horseshoe magnet, or 2 opposite poles of 2-bar magnet. Okay. Inside which the magnetic field is like this. This is the ABCD armature coil. Here S1 and S2 are 2 split ring. Later we will discuss slip ring. Okay. This S1 and S2 are known as 2 split ring. That means semicircular ring like this. This is like this. Okay. 2 split ring. In the middle the axle is passed. Okay. And here the brush B1 and brush B2. S1 and S2, 2 split ring. And fourth part B1 and B2, 2 carbon brush, that is made up of graphite. Actually what will happen, this armature coil here ball bearing is there. Okay, that means it will freely move around the axle. This one is the axle. Along with this 2 S1 and S2 split ring. Okay, in your book the diagram is little bit wrong. Actually the armature coil is connected with the brush, that is incorrect. That when the armature coil will move, the brush will move, that which part is the stationary to provide the current. Okay, so that is wrong. Actually the armature coil ends will be joined with the split ring. It's okay. Now what will happen? When here this is positive, this is negative, here the current will pass through B1, then S1, like this it will pass. Okay. It's okay. When you switch on, let's say here the switch is there. When you make the switch on, then the current will flow like A, B, C, D. That means brush B1 to S1, then A, B, C, D, then S2 to B2. It's okay? When current pass through this armature coil AB, now apply the Fleming's left hand rule. What will happen? This is your north to south magnetic field direction. This is your direction of current, but current will move like this. So this armature coil will move into the page. Just look here. This is the direction of magnetic field. This is the direction of current I am showing. So this part will move into the page, and in this part current is in downward direction, and here it is north to south. So it will move outward. That means like this. So this here the force will act in downward, here the force will act upward, like this. So it will start moving. Okay? So once it start moving means after a half revolution, let's say here like this, after a half revolution, what will happen? You just imagine, this will come here, this will come here. They get detached from both the brush. Okay? No current will move. Current flow will stop. But due to inertia of motion, they again move like this, they will move like this. Once move means this S2 will connect here, S1 will connect here. That means DC side will come here, AB side will come here. And current will move in same direction. So again it is downward, it is upward. So like this the motion will continue. It's okay? So this is about the working of the motor. Now, what are the factors affecting the rotation of motor? You can write down first. What are the factors affecting the rotation of motor? That means if you want to speed up the motor, which factors you have to notice? First one, strength of the magnet. Write down on your copy. Strength of the magnet. That means if the magnet is more powerful, then the rotation of the motor will be faster. It's okay? Second one, strength of current. If more current will pass through the circuit, the fan will speed up. You know this? It's okay? So, second one, the current. Strength of the current. Third one, number of turns you made in the armature coil. You know that when the fan of your coil will get burnt, you will give it to the mechanic. When he repair the coil, you will notice that he will rotate the copper wire around it number of times, thousand number of times they are rotating. That means as the number of turn goes on increasing, the magnetic field strength will created inside the coil will increase. That means the rotation of the fan or motor will faster. So number of turns you have made here, more number of turns, then the rotation will be faster. Then fourth one, surface area of this armature coil. Larger surface area of the armature coil, the motion will be faster. Smaller surface area, motion will be slower. It's okay? So these are the four factors on which the speed of the motor depend. It's okay? You know also what are the devices using motor. That means electric fan, grinder, water pump, washing machine, CD player. It's okay? Mainly in them we are using the motors. Then page 233 blue box question, state the Fleming's left hand rule. You can do this. What is the principle of an electric motor? The principle I am saying you, that the force acting on a current carrying conductor when placed in a magnetic field. Then question number 3, what is the role of the split ring in an electric motor? That means every half turn the split rings are changed their places. So the current will move in the same path. So the rotation of the motor will speed up. It's okay?